This is the CP Geometry 10.6 Secants, Tangents, and Angle Measures lesson. So to start off with, a secant is a line that intersects the circle in two different points. So basically like a chord, but it keeps going. So I labeled X and Y on the circle. The line goes the whole way through and it goes indefinitely, so arrowheads at each end. Again, it's a line that intersects the circle at two different points. Again, it's like a chord, but it does keep going. If two chords or secants intersect in the interior of a circle, then, I'll pull back here so you can see the whole thing, the measure of the angle formed is 1/2 the sum of the measure of the intercepted arcs. So let me scan over to the picture quickly and I'll come back to the formula. So here I have my picture with QR and SP. Just like slicing a pizza or a pie, I have 4 angles in here. So for an example, angle 1, so this one here, angle 1 is 1/2 of the 2 arcs added together. So the 2 arcs are PQ here, it's based off of angle 1, and the other one also RS. Kind of creates that vertical angle issue right here. So QP and RS add together, and then you take half of that and that'll give you angle 1's answer. Okay, again, the example is angle 1 is 1/2 of PQ plus RS. Add the arcs together, take half of that result, and that gives you the angle measurement. Okay, let's practice that. So angle 1 here is the one they're asking for, angles 1 and 2. Angle 1 here, if you add these together, 30 plus 40 is 70. Take half of 70, you get 35, so angle 1 is 35. Now, this is a straight line. It doesn't have to be a diameter, but it is a straight line, and we're talking about supplementary angles right here and here. Angles 1 and 2 are supplementary, so this is 180, and angle 1 is 35. 180 minus 35 is 145. Moving on to the second example. They're asking for 1 and 2 again. I'm going to start with 2 this time because I have the arcs. So 65 and 25 is 90. Half of 90 is 45. So angle 2 is 45. These are now supplementary. Angles 1 and 2 make a straight line. Angles 1 and 2 are supplementary. So if this is 45, that's 135. So take whatever 2 arcs they give you, find that angle first, and then find the one beside it because they're supplementary. Subtract from 180. Then it goes on to say, if an inscribed angle is formed by a tangent and a chord, then, and again I'll pull out so you can see the whole thing here, the angle is 1/2 the measure of the intercepted arc. So angle 1, let's go over the picture here, angle 1, so I have a chord and a tangent. Chord just goes from edge to edge, doesn't go the whole way through like a secant does, so edge to edge, and a tangent, so this angle is then formed right here. So angle 1 is 1/2 of the intercepted arc. The arc being arc AB. So the chord hits the tangent, forms an angle. This is the intercepted arc. So this is 1/2 of this. Angle 1 is 1/2 of arc AB. And then we'll go on to the next part. It says if an angle is formed in the exterior of a circle, then, and again I'll pull out again, the angle is 1/2 the difference being subtraction of the measures of the intercepted arcs. There are 2 of them. So there's several different ways this could happen. You could have 2 secants. Here are the intercepted arcs. You could have a secant and a tangent. Here are the intercepted arcs. Or you could have 2 tangents. Here are the intercepted arcs. Okay, so 3 different circumstances under which that could possibly happen. So let's try a couple. It says find X. Here is X. So that's going to be 1/2 of the intercepted arcs. Well, the intercepted arcs are 120 and 50. It's 2 secants. Cuts this and this off of the circle. So 120 minus 50, because again, you're doing subtraction, 70. 1/2 of 70, X is 35. And we'll go over to this one, a little more complicated here, as you can foresee here. A lot going on. Sorry for the scribbles. You're looking at the whole circle. This angle is given, so you know what the answer is. You're missing part of the question. So these are your two intercepted arcs, and it takes up the whole circle, if you notice. Back over here, the intercepted arcs were only part of the circle. This one takes up the whole circle. So you have a great big arc here, and then this arc in here. So it's the whole thing. So if this one is x, to find this one, it's just 360 minus x, because we all know the whole circle is 360. So if I do 360 minus this, I state it literally as 360 minus x. So this becomes complicated with the algebra. So here's what the algebra does. We have the answer. It's equal to half of the difference of the intercepted arcs. It's always the bigger one minus the smaller one. Of course, bigger minus smaller. So x is the bigger. 360 minus x is the smaller. So here's the issue now. You're going to have to use the distributive property. Distributive property obviously keeps that negative, but makes that positive. Negative times negative is positive. So x plus x is where the 2x comes from. So 47 is equal to 1/2 of 2x minus 360. So here's what I did now. Instead of multiplying through by a half, because I know nobody likes fractions, let's just get rid of that by multiplying it over here. 2 times 47 is 94, equals 2x minus 360. Now we can finish it up easier. Add the 360, divide by 2, x is 227 degrees. Obviously, email me with questions about any of these issues. Last example here. Here are my intercepted arcs. How did I find 140? Well, 70 and 150 is 220. Again, I know the whole circle is 360, so 360 minus 220 is 140. So now I have my two intercepted arcs of 140 and 70. So I subtract those, I get 70, take half of that, 35.